Welcome students. Now we are entering to our next topic, that is same chapter 1, fifth problem we are going to do now. So these problems you just listen what they given the concept from which we can able to understand which topic we are going to discuss in this problem. Okay. The figure shows very clearly very important problem. The 5 charged lumps of plastic and an electrically neutral coin. The cross section of the Gaussian surface. They very clearly given which topic we are going to study here from the given problem. So most of all the students will have some doubt when they given the problem, this belongs to which topic in the chapters. Now everyone can able to first read the question, you can able to understand which area. This is Gaussian surface. So generally what formula are going to see? Gauss law. So you know everyone about the Gauss law formula. Phi equal to Q enclosed by epsilon naught. That is the formula of Gauss law. So don't be panic of see the diagrams like this type of questions given in the problem. First listen very clearly. They given Gaussian surface. What's the net electric flux through the surface? They are asking here as electric flux. So electric flux means you know what they are telling to find out here as phi E. That is electric flux they need to find out here. Okay. Through the surface they given Q1 equal to Q4 equal to plus 3.1 NC, that is nano coulomb. Then Q2 to Q5 they given as 5.9 nano coulomb, and Q3 is nothing but 3.1. This is also nano coulomb. Okay. Now we have to find out this question. This 1 rupee coin, this charge is Q1 here, this Q2 here, Q3 here, and this is Q5 here. The another charge Q4 is placed here. Okay. Now everything is given. The very important interesting question. This we get 5 charged lumps of plastic and electrically neutral coin. The cross section of the surface there is indicated that they are telling to find out the net electric flux through the surface of this given question, that is 3.1 and 5.9, and they given 3.1 nanocoulomb. First we have to write the data, very important thing for the problem, because this is a very important thing you have to know and find out the data. So what they given here as Q1 and Q4, I am just written here as Q1. I can write anything, only one, Q1 or Q4. So we can give us Q1 because Q1 equal to Q4. Read the question very clearly. So Q1 is equal to, they given us 3.1 nano coulomb. Finally we will put this value, we will do the calculation. So second charge Q2, what is the given Q2? This is Q2. Okay, Q2, Q5, 3 up to Q5 both are same. Q2, Q5, 5.9 nano coulomb. 5.9 nano coulomb. Q3 they given minus 3.1 nano coulomb. Okay, so Q1 equal to Q4 I am taking as Q1. So Q2 equal to Q5 I am taking as Q2. Q3 they given. So we have 3 charges here, Q1, Q2, Q3. So what we have to find out here? Electric flux. Okay, fine. You know generally meaning of electric flux, definition of electric flux is based on Gauss law. The total number of electric lines of forces crossing per unit area of a conductor is called as electric flux. So the given data clearly they are telling to find out electric flux also. So this is Gaussian surface. This is only Gaussian surface. This is only Gaussian surface of the given problem. Okay. So which formula is suitable here? What is the formula? What is the formula for this problem? Phi E is equal to Q enclosed by epsilon naught. This is the formula. So data we are writing here. To find is to electric flux. This is to find. Okay, wow. This is the formula. Now you can go for solution. Okay, what we are going to do solution here? So data they given to find the electric flux, formula they given. How to do this problem? Everyone will get some disturbance and thinking how to do this type of problems. Very easy only, nothing wrong in it. That's what I am telling here very clearly. The 3 charges given, the 3 charges which is located in the lump of the plastic elastic medium neutral coin contains of the 3 charges, that is up to 5 charges, Q1, Q2, Q3 and Q4 and Q5. So what they are telling, the cross section of the Gaussian surface they given is indicated. So net charge they given the value of these charges q1, q2, q3 and all they given very clearly. So we need to find out the electric flux. We know formula q in phi equal to q enclosed by epsilon naught. Epsilon naught is constant, we know everyone the value 8.854 into 10 to the power of minus 12. So charge only we got to find out in this problem, very easy. So all the charges you got to add because everything which is placed inside of the Gaussian surface. So we have to sum all the charges. Then you can find out easily the electric flux. How I am going to do, see, listen carefully here. Q1 plus Q2 plus Q3 by epsilon naught. This is the solution we are going to do, adding all the charges according to the law of superposition, and moreover all the charges which is placed inside of the lump. So we have to add all the charges in the plastic medium. So and then we can add all the charges which are placed in same Gaussian surface. It's not out of the Gaussian surface. So no need to worry about this. We have to add all the charges. Phi equal to q1 plus q2 plus q3 by epsilon naught. So we have to add all the charges. So just adding all the charges. Data to find formula solution. Next we can do the solution very easily. Phi e equal to, what is q1, q2, q3? 3.1, 5.9 minus 3.1. Okay, very easy. 3.1 plus 5.9 minus 3.1 whole into, you can take common as nanocoulomb, into 10 to the power of minus 9 divided by value 8.854 into 10 to the power of minus 12. This is epsilon naught. That is permittivity in free space, air or vacuum. Okay, now we are going to do the solution. So plus 3.1 minus 3.1 will cancel. So 5.9 into 10 to the power of minus 9 divided by 8.85 into 10 to the power of minus 12. Okay, now if we do this calculation, we will get the answer very easily. Here is minus 666.67. We'll do division, you will get this answer and make this power very clearly. Minus 2 will go upward, it becomes plus 12. 12 minus 9, it becomes 3. 10 to the power 3. Because minus 2 will go to upward, become plus 12. 12 minus 9 becomes 3. 10 to the power 3. Unit of electric flux is Newton meter square Coulomb inverse. This is the SI unit of electric flux. Okay, this is the answer of the problem. So do this calculation, you will get this answer. Minus of 666.67 into 10 to the power of 3 Newton meter square Coulomb inverse. Very easy problem. Just go through once again and understand the problem very well. Then you can able to understand this concept also very easy. Okay students, please listen it. Remaining problems we will see on next videos, upcoming videos. Okay, thank you students.